So now we're ready for part 2. Okay, so when we talk part 2 here, what we're going to be worrying about is calculations with significant digits. So here we go. Okay, so one thing to remember when we talk uncertainty in science, or really in terms of any measurement, any number that you see, when we talk about that uncertainty, it was about the validity of the number. So we're talking about accuracy. We cannot be more accurate than our least accurate number. We can't overstate our accuracy. So when we talk about this then in terms of calculations, it depends on the calculation we're doing. So if we are doing addition and subtraction, we need to pay attention to the decimal place. So addition or subtraction, we look at the least decimal place. For example, if I have numbers like 25.1 and I then have 14.6, 0. Let's make that 6.2, 0.003, 0.006, and let's say 2. Okay, and I'm going to add all of this together. All right, so I'm going to add it up, and it adds up. Okay, I'm going to put it over here since I ran out of room, 41.729. Okay, so let's go through and count our decimal places. Okay, I have 1 decimal place here. I have 2 decimal places here. I have 3 decimal places. I have 3 decimal places. I have 0 decimal places. My answer currently has 3 decimal places. So if we have to pay attention to least, well, 0 is the least. That means I have to get rid of all of these. So they go away. Now, remember basic rounding. Okay, so if I round 41.729 and I can have no decimal places, well, that's going to round up. So that means my answer is actually 42. I haven't overstated my accuracy. Now, when I multiply and divide, it's a little bit different. Okay, so when we talk about multiplication and division, we round to the least number of significant figures. So, for example, let's take 3.5 times 4.10 times 2. Okay, and we should get 28.7. Okay, so if I get 28.7, now let's go back through. We're supposed to be figuring out the least number of significant figures. So in this one I have 2, I have 3, I have 1, and I have 3. So I have to have the least. I can only have one significant figure. Okay, so now we run into a problem, 28.7. Well, really what we want to do is we want to round that to 29. That's typically what we want to do, but 29 has 2 significant figures, so I can't do that. I can only have 1, so now I have to figure out what's going on. Okay, whenever you round, you always start from the left side. So here's my 28.7. I'm going to start from the left side and start my count. I can only keep 1. That means I keep this number right here. Notice it's in the tens spot, right? And that means all of this has to go away and cause that to round up if appropriate. Well, it's 8.7. It's going to round up. That means I need to put a 3. Well, 28.7 doesn't round to 3, but remember it was in the tens spot. That's why we have zeros for placeholders. So 28.7 will round to 30. 30 is one significant digit. Okay? So, practice. Here's a problem. So you're told a couple of things with this problem. We're going to go through this step by step. You have, keep in mind the rules for significant digits. So we have 0.8801 and we have 3.2. All right, product. Product is the key word there because that tells us we're multiplying and dividing. So we're doing multiplication division. That means in terms of the rules we keep the least number of Sig Digs. So before we ever start and look at our answers, we're going to look at what we're given. Okay, 0.8801, well my decimal's present. Pacific side, 8. There's 1, 2, 3, 4. 4 significant digits. 3.12, again, the decimal is present. Start on the left. Pacific side, 3. So that's 1, 2, 3. So I have 3 significant digits. I can keep the least, so that means my answer has to have 3 significant digits. Well, if you come over here and look, you can see that every single one of these answers is exactly the same thing. The difference is the number of significant digits they kept. 2.75, well, what do you know? There's 3. So we know we're good, but let's look at the rest. I have 1, 2, 3, 4, so this one has 4. 3, that has 1. 2.7, there's 2. 2.74591, 2. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, the only answer that has 3 significant digits is this one, so the answer has to be 6. And again, we don't really care about what the answer is. These are all the same thing. What we cared about was how many significant digits did I get to keep in my answer? Well, let's make sure we were right. Sure enough, that's it. That's all there is to it.